Hi, I'm Andy and this is question 4 on the AQA Decision 1 paper from January 2006. For more questions on this paper, click on the eye in the top right corner. So in question 4, the diagram shows a feasible region of a linear programming problem. And on the feasible region, we need to find the maximum value of 2x plus 3y, 3x plus 2y, and the minimum value of minus 2x plus y. So we'll start with 2x plus 3y. And the way that I'm going to find the max value is by drawing an objective line. So in order to draw the objective line for this function here, I need to choose a number for p. Doesn't matter what number you choose for p. We might get various different objective lines, but they'll all be parallel to each other and they'll all give us the same final answer. So a sensible choice though is any number that both of these numbers go into. So first of all, you might think, right, well, I'll let p equal 6 and then I would get 2x plus 3y equals 6. And then if you wanted to draw this line, you could use the cover-up method. So if we first make x equals 0, we'd get 6 equals 3y, which means y is 2. So we'd get the coordinates 0, 2 on the line. If we then thought about what happens when y equals 0, we would get x equals 3. So that would be 3, 0. And if you've got 2 points on a straight line, you could just draw a line through them. However, these 2 points would be very close to the axes, and it wouldn't be very easy to see what's going on. So it's sensible to choose a number that is larger than 6. So I'm going to choose 60 instead. And the effect that will have, as we'll see, is to multiply the non-zero parts of the coordinates by 10. So once again, if we let x equal 0, 60 equals 3y, that would mean y equals 20. And if we let the y part equal 0, we get 2x equals 60, which means x would be 30. We can now draw this line on from 0, 20 to 30, 0. And we're looking to find the maximum point in this region. To do that, we take a ruler and we put it parallel to the line. And then all we'd have to do is move our ruler up until we find the point where it last leaves the region. So we've gone past the bottom right corner and we've gone past the point in the middle there. And so the last point is up here at the top. Now on the computer, I can just move my ruler and keep it parallel. It's a little bit more difficult when you do it on paper. So one thing you can do, if you need to, is just very faintly draw yourself a dotted line every time you move your ruler up until you get somewhere a bit closer to your region where you can actually tell. And then at the end, just rub out those little dotted lines. So if I do it like that, I could from here see that it's going to be the last point there. And so reading off this coordinate, which you can probably do easier than me on paper, we get that it's at 30, 70. So then all we need to do is substitute those values into here. So we would get p equals 2 lots of 30 plus 3 lots of 70. 2 lots of 30 is 60 plus 210 gives me 270. Okay, next up we're going to do 3x plus 2y. Very similar function to what we've got above, so a sensible choice would again be 60. Using the cover-up method again, when x is 0, we would get y equals 30. And when y is 0, we get x equals 20. Now that we've got our points, we can draw a line again. So we'll call this line objective line 1, just so we can distinguish them. So objective line 2 is going to go from 0, 30 up here, down to 20, 0. Okay, and if we put our ruler on that and move it up, this time the last point we leave in the region will be the top right corner here. And that point is at 60, 40. And if we sub that in, we would get p equals 3 lots of 60 plus 2 lots of 40. 3 lots of 60 is 180. Add another 80 gives me 260. The third one is a little bit different. We've got to find the minimum value this time of minus 2x plus y. For this objective function, because we have a negative here, it will be difficult to draw using the cover-up method because we'd end up with negative values in the coordinates. So instead, we're going to think about the gradient and intercept for this. And if I rearrange this equation, I could get y equals 2x plus p, which is simply a line with gradient 2 and intercept p. Well, to simplify things, we'll let p equal 0 here. So we'll draw our objective line as y equals 2x. which is simply a line starting at 0 with a gradient of 2. So to help me draw that, I'll just add a coordinate on here at 60, 120. And so this will be our third objective line. Once again, we're going to use our ruler to find the point we're looking for, but in this case it will be a minimum point because we're trying to find the minimum value. So rather than moving my ruler up, I'm going to move my ruler down. So starting from here, if I move it down, it should be fairly obvious where it's going to leave the region. It's going to be over here, which means my minimum will be at 7510. In which case P equals minus 2 lots of 75 plus 10. 2 lots of 75 will be 150, so that's minus 150 plus 10 is negative 140. Finally, in part B, we need to find the 5 inequalities that define the region. We'll start with the horizontal and vertical lines because they're fairly straightforward. We've got a line that goes horizontally through 10. That will be y equals 10. In this case, we want the region above it, so that will be y is greater than or equal to 10. We've got a vertical line going up through 20, and we want to the right of that line, which tells us that x has to be bigger than or equal to 20. We've got a line here, which if we look at the gradient, it's going 20 across for every 20 squares up, so that's just a gradient of 1, and it's got an intercept of 40. That tells us it's the line y equals x plus 40, and we want below the line, so we want y is less than x plus 40. Less than or equal to x plus 40. We've also got a line that goes through 100, 100. Okay, and you need to be able to spot that these are lines of the form x plus y equals something. So because it goes through 100 up here, this line is x plus y equals 100. And we want below the line, so we want x plus y is less than or equal to 100. So the last one's a bit more tricky. It's this diagonal line going down here. It's obviously negative gradient because it's going downwards. And if we look at a triangle on it, we could go 20 to the left and 40 up. So the gradient of this line would be m equals distance up, which is 40. Well, it's negative first of all. 40 divided by distance across, which is 20, which would give us negative 2. So the equation of this line will be something of the form y equals negative 2x plus c. If we sub in a point on the line, we can find the value of c. So we know 80, 0 is on the line. So 0 equals minus 2 lots of 80 plus c, giving us c equals 160. So this line is y equals minus 2x plus 160, which we can write in the form that we often see for linear programming as y plus 2x equals 160, and we want below the line, so y plus 2x must be less than or equal to 160. And there are our 5 lines.